Okay, you should have collected your data for your project now. Now we need to know what to do with it. First off, the why we collected the data. It's not just the conclusion. I mean, most of the conclusions we can draw from this we already discussed at length in class. What's more important is about how we go from using data. It is a strong foundation to get to the conclusion. The conclusion has to be supported by the data, and it has to be data that we get naturally because the data has to come from nature. So, data from nature, we build a conclusion upon it. That's a main component of science. Let's start with the sun. First off, a couple of pieces of information you should have is the length of the shadow. You should have the time and date the shadow was cast, the direction the shadow was, and of course the height of whoever was casting the shadow. So I have my object here casting a shadow, then I get the shadow itself. And if I follow a line from end of my shadow to wherever it was, that should lead me to the sun. So this is the angle here that's going to tell me how high in the sky the sun is. Now, this, okay, length we'll call L, height we'll call H. So this is the length of my shadow, this is the height of whoever's casting the shadow. I have a nice little right triangle here. So I can calculate this very simply. The tangent of that angle equals the height of my object divided by the length of the shadow. Now to figure out what my angle is, I actually am just going to take the inverse tangent of the height divided by the length. Now this is a basic function on your calculator. You should be able to find it. If not, please see me for extra help. But now you should be able to create a simple data table where you have now the angle, you have the time, the direction, and the date. And from this information, we should be able to see what's happening to the sun throughout the course of a month. Is it getting higher in the sky, lower in the sky? Is it hitting the same spot sooner, or is it hitting it later? Now, if you didn't take your data at the same time every day, well, that's a new variable. See, we should only have one variable in our experiment between trials. And that really should be the time, that should be just the date. When did we take it? If you took it at a different time every day, well, now that's two variables. So we use the same height. The direction will change because of these variables. So we should have only had either the time stay the same or you did throughout the course of a day, but that wasn't what we're looking at here. So you really should have had the same time. If you took it at different times, I mean, they're off by like 2-3 hours. Well, that data may not be usable because there's not much we can pull from that. But if you still have questions, please see me. Now, if you were paying attention to the moon, then information you should have for that should be first, I think the easiest thing would be the appearance of the moon. You should have the direction of the moon, north, south, east, west. And then, of course, you should have the angle which you measured with the clinometer. Now, this should tell you then, first off, appearance, talked about phases. Tell me what happens to the moon throughout the course of the month. You should have seen this. Direction and angle tells you where the moon was in the sky. So one thing you could easily do to help analyze your data is to use a little drawing. Maybe have the east be over here, the west over here, in the middle is due south, and have this be like, the top of it could be like 90 degrees up, the bottom is 0 degrees, and kind of draw where your moon was throughout the course of that month and draw what it looked like. So maybe it took a path like this. Now, if all of a sudden I see that the moon's coming up at different times or showing up at a different place, that's going to be part of my conclusion. I can say that. I can bring in something about phases, but I must be able to show that using my data. And so now you're going to take the data you collected, maybe create something like this to help explain it, and now you can lead you to your conclusion. For the stars, you're going to look at the same kind of thing as the moon. You should have the direction that the star was. You should have the angle the star was, how high in the sky, and of course the date and time. What you can do is create a simple little drawing then, showing that, let's put east over here, west over here, and this is if I was looking to the south. If you're looking at the direction, you can set that up for whatever direction. If your constellation is mostly to the south, put the south in the middle. Your constellation mostly to the east, put the east in the middle. But then you want to draw where your star was for each of those time periods. And I'm just making up points here. Put your date with that. Use this to help explain what happened to that star's position in the night sky throughout the course of a month. You should have at least 15 points there. And if the star is really close some nights but then moves farther apart, you need to show that. But then your conclusion should be, is the star getting to that spot earlier every night or later, or is it appearing in the same spot every time? Does it get higher? Does it get lower? It shouldn't really change anything in appearance. Now, once you have analyzed your data, you've organized in a way that you can try to pull some information of it, you need to write up a paper. Your paper, of course, should have your names, both your names on it, and yes, one paper per group is acceptable, but both partners need to work on this. If one person does it and the other person doesn't have a clue what they're doing, it's not going to help you any. You're just not learning. You got to make sure you're both doing this. The title could just be whatever you want to come up with, but you should have a title. Objective then, statement describing what your experiment was and what question you're trying to answer. What were you observing? Your materials, what tools did you use to get your data? Explain in detail what you used, how you collected it. Step-by-step directions for how you collect is your procedure. Now, materials, procedure, those you could have in kind of a bullet format, kind of like I have here. Your observations and conclusion, you really need to be writing out as a paragraph. That should be a narrative. Your data, however you have it collected. Objective, again, it's a statement. You're writing it out. It's not a bullet point. So materials and procedure, bullet points, observations, conclusion, you're writing as paragraphs. Data, some of it should be in a data table. You can include graphs or a diagram or something to help make sense of your data. Your observation is a paragraph describing anything you notice while obtaining your data that may have influenced your data or has to do with your original question. So it's not data where you measured it, but something else you have. Maybe you noticed that it moved more during this time, or maybe it was not visible during these dates. Well, why was that? Your conclusion then, at least a paragraph 2, describing what statements you can make from observing your data. Your conclusion has to be backed up by your data or it's invalid. If your data does not support your conclusion, you're just copying something from somebody else, you're copying from the book, it's pointless to you. We need to figure out how to use our data to come up with a conclusion. And every experiment can tell us something. It's just that sometimes, there are such things as one experiment better than another. So you need to look at your data, figure out what you can from it, analyze it, write it up. And this is due, of course, by Friday, May 18th. If you don't have it done by that last Friday and turned in, you will not get credit for this. You need to get it done by then. If you have any questions, see me after school, before school, during class. But this is due 2 weeks from this current Friday, making the due date Friday, May 18th.